recording. All right. Well, welcome to cisp300. And as I said, it's 1 minute past 10:30 already. So if you can find a seat, go ahead and sit down, so we don't have a whole bunch of people standing up. It's definitely getting warm in the classroom. So the first thing I'll do is to go over the syllabus, and just so that you guys know, where to get your classes and information of this class. This class does not use D2L, Desire to Learn. Instead, we use Moodle instead of D2L. And all of this information will be available to you. Many of you have, or all of you who are enrolled in the class should have gotten an email message that you are enrolled in the class. It gives you your user ID, which is just a student ID, and your initial password, which is some 6 random letters. How many people already have an account on Moodle, or has just gotten that message recently? Very good. Okay. So that's how you log in. The URL to the website is there. Your user ID, which is just your student ID, is there, and so is your initial password. Okay. Once you log in, you won't see exactly what I'm seeing here, because you will only have one class being displayed here as my courses. I have many courses because I teach other classes, and sometimes I keep some of my other classes visible for a long time. Once you click on the class, you will get to this page, and you will see from the title, this is for Spring 12, Tuesday, Thursday, which is this particular section of cisp300. All the resources that you need for this class are here in Moodle. What you need to read is here. Your homework assignments will be here, and but the quizzes will be or your exams will be done on paper, because we cannot get to the lab. There's no way the lab can fit all of us over there. Okay. But once it's graded, it will all be displayed here under your grades. Are there any questions so far about using Moodle? Yep, go ahead.
Enrollment classes, you get that email?
If you had an account already, your account is still active.
Okay.
So if you did not receive a message, that means you have an account on Moodle already. If you forget your password because you have not used it for some time, here's how to reset it. So what you need to do is to click on this link here. It's a video clip of how to reset your password.
Okay.
It's a 2-step process. Basically you have to first request to reset your password, and then it will send an email to your iMail account.
Sure.
In that email message, there will be a link. You click that link to confirm that you did request a change of your password. The second click will trigger Moodle to send you a second message that contains a temporary password. Then you can log back in.
Okay, perfect. Thank you.
It's a 2-step process, so that someone other than yourself can request a password change all they want, but it won't actually do any changes to your account.
Okay.
Because otherwise, you can imagine, sometimes it can be very troubling. If someone knows your student ID, they can keep changing your password so you can log in. So that would be bad. All right. So the first thing is we'll go over the syllabus. Just information about myself, the class, my expectations, and so on. I do not print any syllabus or any syllabi anymore because I think it's a waste of paper, for one. If you want to print it out, you can print it out yourself and put it into your binder, but I will go over that also. There are 2 versions of the syllabus. One is a PDF, the other one is an HTML document. I'm using the HTML document in the class because I can zoom in more easily. If you want to print it out, you can choose to use the PDF version instead of the HTML version. Are there any questions? Any questions? I'm just confirming that it is still recording. I think it's recording, but it's not. Well, after you guys watch it, let me know whether the volume is right or not. Sometimes it's too high, sometimes it's too low, so it all depends. All right. The class code is 10960. So for those of you who will be adding to this class, This is a very important number. Okay, remember this number and write it on your add form when it is time to add to the class. I will handle all the add requests later because I have to find out how many people actually make it in the class, and that will determine how much room we have in the class. The class size is 44. In other words, I can have 44 enrolled students in the class. The wait list of this class is about 20. In other words, there are 20 people on the wait list, and then there are some people who are not even on the wait list, trying to get into the class at this point. Okay. I cannot increase the class size any more than 44, so that part is going to be constant. The course title is Algorithm Design / Problem Solving. And here is the description. It's just pulled from the catalog, so that should not be surprising at all. The student learning outcome is something that you typically won't see in the syllabus. It defines what you should be able to do after taking this class. So you should be able to define operators, including arithmetic, comparison, and logical operators, and so on and so forth. So we'll go down this list as we talk about the content of this class throughout the semester. Time and place. Okay, you're here, so that means you already know this part. The number of units is 3. The lecture hours is 54. Can anyone tell me, just by college equation, how much time are you supposed to spend on this class?
3 times the number of lecture hours.
Exactly. So in this case, it will be 150 something hours for the entire semester. 162 hours for the entire semester. Now that number obviously is just an average because it also includes prepping the class, reading the material before the class, sitting here in the class, doing the homework assignments, reviewing the questions for exams, and so on. Some people can spend less time, some people have to spend more time, but this is a ballpark number. We have about 3 hours of lectures each week. So that means you're supposed to spend about 9 hours each week on this class. Any questions about that? I cannot really tell how much time you spend on this class, and neither is that important for your grade. Some people can be here, okay, just be in the lecture, and they absorb all the material during the lecture, and they spend no time studying at all, and they can still ace the class. Some people may have to spend a lot more time to understand the material. So I cannot really tell you how much time you have to spend in this class to be successful. The final date, this is also very important because I cannot change it. It is going to be May 10th from 10:15 to 12:15. So make sure you allocate that block of time to make yourself available during that time for the final exam. Information about myself. My first name is Tech and last name is Aoyong. This is a hyperlink to a wiki page, Wikipedia page, just in case anyone is interested. I'm not that interested. My office is room 7, or number 7, of room 133 of liberal arts. It's 1 aisle over to the other side. Does everybody know where 133 is? It's just 1 aisle over on the other side. It has a glass door, and that's the division office. My email accounts, there are 2. You can use either one. This is the school account, and this is my personal account, but you can use either one to reach me. Office hours are kind of scattered around a little bit. On Mondays and Wednesdays, it's from noon to 1 o'clock. On Tuesdays and Thursdays, it's in the evening from 6 to 7 o'clock. And on Fridays, it's online, which means I'm not going to be in my office. If you need to talk to me in person and you cannot make it to any of this time, let me know and I can schedule some additional time. Okay? Are there any questions about my office hour or how to get in touch with me? I intentionally skipped my phone because that's the worst way to contact me. Okay, if you want to contact me, see me in person or send me an email. The phone is really the last resort. Any questions? No questions? All right, just keep moving on. What I expect from you guys during the class, universal expectations. Basically, no disruptive behavior. Okay, and over the past 11 or 12 years or so, I have seen some interesting disruptive behaviors in the class. Some intentional and some really not so intentional, but nonetheless disruptive. So anyone who wants to chat particularly or especially about stuff that does not relate to the class can do it outside. If someone wants to bring in their DSI and game with another person, you can do it outside. Text, talk, eat, drink, and so on. These are all allowed, just not in the classroom when I'm teaching. Okay. This is not an exhaustive list of disruptive behavior, and I'll give you one example. There was one student in cisp300 about 2 or 3 semesters ago, and he brought in his dog, with him in the class. Now sometimes I have students who need to have their helper dogs with them, so it's not a big deal. I did not think much of it at the time, except in this case the dog is not a helping dog. Okay, it's just a pet, and he or she, the dog was panting the whole time, very loud. I'm talking about so loud that the entire class, including people all the way to the back, can hear it clearly, and so can my recorder. Okay, when it's not panting, it becomes even more disruptive, because if it's not panting, it's licking the student behind it. Very friendly, yes. So I had to tell the student, I understand the dog is important to you, but because it is so disruptive in the class, other students cannot concentrate, so I had to ask the student not to bring the class in the classroom, during the class. So that's, unintentional, but nonetheless disruptive, so I had to ask the student, please don't do this. If there is something that is disrupting you, but I did not know about it, let me know. You can just let me know, before the class, after the class, during my office hour, by email, and so on. No disrespectful behavior and academic dishonesty. Both of these are not going to be tolerated. Academic dishonesty, there's a link to a more complete explanation. Does anyone want me to go over what is academic dishonesty? Well, cheating in general.
Plagiarism, cheating.
Well, in this class, plagiarism is going to be pretty hard, because of the type of homework assignments and the tests that we have. But basically, any deceptive attempt so that a student may appear to be better than the actual capability of that student will be considered cheating. Okay? And I don't care really how it is done. I only care about the intent and also the result of the action. So when it happens, it will be documented for one thing, and it will be sent to the disciplined officer on campus. The disciplined officer will determine the appropriate action in addition to the following. If the cheating is on an assignment, the assignment will get a 0. If it's on an exam, the exam will get a 0, and so on. Okay, so whatever work that involves cheating will not get any credit. Now, this part here is also very important. A discovery of academic dishonesty may trigger re-investigations of prior submitted work. Any prior work newly discovered or confirmed as results of cheating will be retroactively processed. In other words, I can look at a homework assignment submitted before a test, and it was already given points. But if I decide from the test, if I can tell a student is cheating, I can go back and check on the homework assignments as well. And if those assignments are confirmed, results of cheating, then those will get 0 points retroactively. Are there any questions about the treatment of academic dishonesty? No questions? Okay. In the past, especially this last item had gotten some students into real trouble. I got one student from maybe 2, 3, or 4 semesters ago, who I could confirm a case of cheating in one of my exams. So I went back and looked at that student's homework assignment, submission of the homework assignments, and also an exam before the exam that I found the cheating, and I was able to confirm cheating as well in all of those work. So the student ended up having a grade of C dropped to a grade of D. And as a result of that, the student was not able to enroll in the class that he was planning to enroll in the following semester because the prerequisite of a C or better grade was not met as a result. I don't really feel, I feel bad in a way, but on the other hand, I don't really have an option of not doing this because I cannot allow that sort of dishonesty in this class. Okay. Any questions about that? Okay, well, I have a question. I know this student who's sitting next to me, who is struggling in the class. And that student definitely wants to get through the class, was trying very hard. So how am I going to help the student who's sitting next to me without, risking that student, being considered cheating? Does anyone want to answer the question? Oh, let me just, I'll just mention something that's way ahead. This class does not grade by curve. In other words, if the entire class is up to the standard, the entire class can get a grade of A. Okay, so there's no need to intentionally make another student suffer or have a lower grade. We can all have A's in this class. It's not curved. So given that premise, okay, is it possible to help out a fellow student without risking being considered cheating?
Yeah, you can help them understand the concepts instead of just giving them the answer.
Exactly, because if you help the other student to actually understand and apply the concepts, then the other student, will be able to consistently get a higher score. In other words, the score that student will be getting is not inflated, it's not deceptive. Okay, so that's the way to help the other student, a student who needs help. Okay, is to make sure that student understands the material and be able to apply the concepts during a test or a homework assignment. This is a face-to-face class, and that's why I have to mention this. No phone, no drink, no food, and no kid. And that's all written here. Okay, so I didn't invent that. If you want to ask a question, go ahead and raise your hand first before I say, okay, go ahead and ask the question, especially when multiple people want to ask or answer a question all at the same time. As far as attendance is concerned, I will drop students who missed the first class session. So you guys are safe, right? I will drop students with 6% or more in unexcused absences. Now 6%, is really easy to go by. This is a 16-week class, so 1 week's worth of lecture is more than 6% already. I will drop students who do not attend all of the first two sessions, but that's already covered by the second item here, so I guess we don't have to deal with that. I am only required to accept verified military duty, jury duty, and medical reasons as excused absences. All other absences may or may not be excused at my discretion. Okay. Are there any questions about this part? Yep.
So if we ever miss 2 classes, we're dropped?
Unexcused, yes.
Okay.
So if you're excused for one reason or another, it does not count for those 2. The campus health center can verify medical excuses, and it is free. In other words, if one day you just feel, oh, I think I'm coming down with something, and you're on campus at the time, just go to the health center on campus, which is in the administrative building, and ask the nurse to give you a note that says that you are not feeling well on that day, and you should not be attending classes. Okay? Are there any questions about attendance? Questions? Okay. Online does not really apply to this class because this is not an online class. On the other hand, you should check your email accounts because everything that I will send out to you will be sent to your email accounts. Grading, the favorite part, because the curve is really interesting. Anyone with less than 12.5% of all the point values at the end of the semester will get a letter grade of F. Does anyone want to disagree with that? Yeah, I
pretty
think
terrible.
1/8. Yeah, 1/8 of the points, getting an F. I think it's reasonable. A D is between 1/8 and 3/8. Okay, that's a D. And a passing grade with a C is somewhere between 3/8 and 5/8. That's a C already, and you can move on to cisp360 if you get that many points. Yes.
So are you making like this because the class appears to be this hard, or why is this so different than the average grading system that everyone else uses?
Well, these are all centered around 0, 25, 50, 75, and 100%. And I can do it because I don't ask easy questions.
Okay. Alright.
There's no fluff question in any of the exams.
I'll be prepared.
And you will like it too later on in the categories and weights. You will see why it is kind of interesting. A B is between 5/8 and 7/8, and anyone with at least 7/8 of all the points will get an A in this class. Okay. So in terms of categories, we have 4 main categories of stuff that can give you points. Homework assignments make up 20% of your final grade, which is not a whole lot. Now, it is important to remember the homework is not here to give you a lot of points, but it does give you the necessary exercises so that you can understand the concepts. Okay? In other words, one of the homework assignments may worth maybe 2% or 1% of the final grade. But don't skip it, okay? Don't skip the homework assignments, because that one homework assignment, which is only worth like 1%, may help you get a question done in the final exam, which may worth 10% of your final grade. So the homework assignment is just for that. It's an exercise so that you can get the practice that you need to understand the material. The first exam, which is about 1/3 through the semester, is worth 20% of the final grade. And typically, this is the one that most people would bomb on because they're not used to the type of question, they're not used to answering that sort of question, they're not used to the way I ask questions, and so on. So people typically would bomb on the first question a little bit. Not badly, but just a little bit. The second exam, by the time we have the second exam, which is 2/3 through the semester, most people should know what to expect in the exams already. Most people do fairly well in the second exam. And the final exam will carry 40% of the points for this class. And yes, someone can flunk the first, the second exam, not submit any homework assignments, ace the final exam, and still get out of this class with a C. It just has not happened yet.
Sounds like a challenge. Sounds like a challenge.
A grand challenge at that. So it is possible. I haven't seen it happen yet. Most people who get enough points to pass the class after the first or even the second exam will typically ace the final exam as well. Okay, so why settle with a C when you can get a B or an A? The schedule is only tentative, so these are the topics and the dates that we'll talk about those topics for this class. But once again, let me emphasize, these are all tentative. And sometimes we move a little faster, sometimes we move a little slower, depending on what kind of questions I have in the class. Okay. Any questions so far? No questions? All right. Do you guys think it's fair to pass the roll sheet at this point, about 25 minutes after the class starts?
Sure.
Okay, let's go ahead and pass the roll sheet. Okay, the roll sheet only has the names of people who are enrolled in the class, not the people on the wait list or even beyond the wait list. If you are in the class, go ahead and find your name and write down your either sign or just check next to your name. And there are 2 columns, one column for today and one column for Thursday. If you are not in the class on the wait list or not even on the wait list, I have some blank space here as well as a second page so that you can put your name on those columns. Okay, because even if you're not in the class, I want to keep track of your attendance so that later on when there are spots open, I will basically say, yes, I can confirm this student has been attending the class all along, and so that student can be added to the class. All right, so I'm going to start from this side. Before you leave the classroom today, make sure that your name is on the sheet somewhere. So So once again, the syllabus is online. I'm not going to give you a copy. On the other hand, I do want you to confirm that you know where to find the syllabus and that you have read the syllabus. So what we'll do is to do it online. After you log into Moodle, so this only applies to people who are currently in the class. If you're on the wait list, you cannot get into Moodle just yet. There's an activity called I received and read the syllabus. When you click it, it will just, it's not available until August. I said the date wrong. That's a while away. Okay, let's change it back to this month. So what you have to do, once you get in here, is to select one of the two choices and then click Save My Choice. So we only get these two choices. I'm sorry. You can either say yes, I found and read the syllabus, or no, I want to be dropped from the class, which I will do promptly. Okay. Any questions? Think you can get this part done in 2 days? Like 48 hours?
Sounds pretty easy.
I'll bet you that before the end of this class, 10 people will click it already, either through their cell phone, their laptop computers, and whatnot. All right, so that's that. All right, and one more thing, okay, I just want to give people, some warnings ahead of time. I want the homework assignments to be done in LibreOffice or OpenOffice. Almost all of the homework assignments will be done in a spreadsheet, okay? And the only spreadsheet program that I want you to use is LibreOffice Calc or OpenOffice Calc. They're basically the same product. Someone will say, but I don't have it. I don't want to pay anything for LibreOffice or OpenOffice.
It's free.
It's free, yes. You can still buy it from eBay or something, but it is free otherwise. Okay, but there are two ways to get it. Okay, even though it is free, there are two ways to get LibreOffice or OpenOffice. Okay, if you just type LibreOffice, L-I-B-R-E, Office, you will find LibreOffice.org. You can download it and install it from there. This approach works. It works really well. It is free. It only has one drawback. Okay, the only drawback of this approach is if you install it on your home computer, it will only be installed on your home computer. Now, if you have access to different computers throughout the day, like your home computer first, and then maybe your laptop computer, maybe later on your office computer, and so on and so forth, this may not work very well because then you'll be only be installing it on one single computer, and your office computer may be locked down so that you cannot install anything on it. So this is one solution. It is efficient this way because it will run fast. But if you want another solution, you can go for the portable version of LibreOffice from portableapps.com. Now the portable version of LibreOffice, it only works in Windows, okay? So if you have a Windows machine, you can use this approach. What this does is you can install the program on a, okay, you can install this program on a, okay, let's not block the student over here. If you, okay, do you guys mind sitting maybe along the aisle? So this way you're not going to block the student looking at the screen. So what you can do with a portable version is you can install it on a thumb drive or an SD card or any type of portable storage device, usually USB or compact flash card. Or yep, go ahead.
If we're using a different editor, can we export to that format?
I do not want you to use that that way of doing the homework assignments because there are certain properties of the documents that I want to preserve. And anytime you open it in Microsoft Excel and save it as ODS, some of that information is lost. So that's why I want you to use LibreOffice natively for homework assignments in this class. Okay. Now this one is nice because you can install it on a thumb drive. So after that, you can take that thumb drive to just about any computer running Windows, plug it in, find the application, double click on it, and it will run from the thumb drive. Okay, so the second option gives you, more flexibility, but it will run slower too. Okay, the second option does make it run slower because it depends on the speed of your external storage device. External hard drives tend to be pretty fast. SD cards, especially class 4 or class 6, are definitely fast enough. But on the other hand, if you get a $5, 8 GB, thumb drive from a no-name brand, it can run very slowly. So you have to keep that in mind. For those of you who have Mac OS X, you can install LibreOffice natively to Mac OS X. For those of you who have Linux running natively on a computer, it is available for Linux natively as well.
Get install LibreOffice. Get install.
Apt-get install, yep, aptitude install LibreOffice, we'll get it installed. So are there any questions about this part of the class, this requirement? No? It also shows you how much memory you will need to get it installed. Unless you want to use all languages, which means you can localize LibreOffice to any language you want. If you go with the English version, it will take less than half a gigabyte on your external device. I would say about 12 years ago, half a gig is a lot of space. Okay, I think the largest memory card they had at that time is about 128 megabytes. Okay, but these days, can you still buy a compact flash card with external storage, USB thumb drive with less than 4 gigabytes from the shelf? I'm not talking about eBay or
I think that's
Craigslist.
Walmart, I think.
Maybe Walmart?
Walmart has them for like 2 gigs, I think. It's the smallest I've seen.
Okay, and how much is that?
Like $3.
$3. It's better to get an 8 gig,
Yeah.
For maybe $10 or so. That will just give you a lot of space for other stuff too. Any questions? Now, there's one more advantage of this portable version. If you customize your settings or options for the portable version, it stays on your external drive. Okay, so that's really nice because now you can whenever you run the application, it will have all your settings with you. Any questions at this point about the portable versions of these applications, of this particular application? For those of you who are interested, portableapps.com also have the same type of application, the same type of installation for different types of applications. If you go to Get Apps, you can get Firefox for the portable version of Firefox, which is nice because now you can save all your bookmarks, you can save all your plugins and whatnot on your thumb drive. So everywhere you go, if you start that portable version of Firefox, it will have all your settings, all your plugins and whatnot with it.
I have a question. If we didn't want to use our laptop, could we use our smartphones for the class? Do we have them?
Your smartphone probably will not have LibreOffice available for it. So
Not all smartphones, but some of them have it.
Really?
Mhm.
Wow.
So
As
can we
long as
use
the
it?
format is compatible, it's okay, it's good.
Sweet.
Yep. So you can find a lot of other applications, that are portable. In case you get an 8 gig, drive, and you're thinking, well, that's kind of a waste for one single class. You can get all sorts of stuff here. There are some games, they're not really open source is not really, famous for games, but you can install games, in a portable way as well. All right. Any questions? Yep.
Which would you recommend, LibreOffice or Open?
LibreOffice is the current version. OpenOffice is kind of the old version. The name change is because of Oracle. Okay, Oracle acquired Sun Microsystems a while back. And as a result of that, Sun originally owned OpenOffice, and that's when it was called OpenOffice. When Oracle acquired Sun Microsystems, it was still called OpenOffice, but because of the acquisition, the entire team who worked on OpenOffice decided to leave Oracle.
Okay.
And they became independent of Oracle, and the outside Oracle version is called LibreOffice.
So it's basically a fork of OpenOffice.
Yes, but OpenOffice is no longer maintained by Oracle. Oracle has no incentive to maintain OpenOffice because it's not, in their strategy at all. So that product, they just kind of inherited it from Sun, but it was not particularly important to them. So use LibreOffice if you have a choice, between LibreOffice and OpenOffice. Any questions? Well, I have a question. I have never used LibreOffice Calc before, so how hard is it to learn how to use it? Well, throughout this class, I will show you guys exactly how to use it, okay? Including some tricks too, how to make it more efficient to use LibreOffice Calc. So don't worry about that part, just get it installed first. All right, so once that is done, we'll start with developers and algorithms, okay? So the boring stuff starts now. Oh, wait, before we start the boring stuff, let me show you where to find recordings of this class, because remember, I record all my classes, and it's still being recorded right now, and I just want to double check the recorder is still up. Yep, it is still recording. So if you want to find the recording of a particular class, you go to youtube.com, and then what you do is you look for the date of the class as well as the course code of the class. This is cisp300, and obviously nothing exists yet for this semester, so you can look for something from last semester. So I'll say 2011. Let's hope 0930 is one of the days that this class met last semester. I'm not sure. And we don't have that, but we have December 8th of cisp300. So you just click it, and it runs. It has my boring voice. Once I turn on the audio, we can play it. All right. So we got a few kind of important things, and some of you may like some of these items. At least the first one, I have extra credit homework assignment. It's called. So that's basically what it sounds like. It's pretty much the same as just staring at the screen here in class, except you cannot ask questions, right? Now, in terms of resolution, because someone would say, well, this is really fuzzy on my screen. I can't really see what you're typing, on the screen. That's okay. Just click this button here and turn it all the way up to 720p, which is a HD resolution, and also just go ahead and maximize it, and you will see that for the most part everything is readable, it's legible on the screen. Okay. Any questions about how to access video recordings of this class? No. Okay. You think this may be helpful?
Yeah, absolutely.
Well,
Like,
it's
what
going
did
to
he
be.
say in class? What did he say?
Actually, there was one time in one of my other classes, someone asked me exactly that question. Could you repeat what you just said 5 seconds ago? And I could not do it because I cannot remember what I just said 5 seconds ago. So I did an experiment. I looked at the file, the video file that was still being recorded, and I opened it with a video file player. And I was able to get back to that point and start playing it. In other words, it's kind of like TiVo. I can, how do you call that, slipstream myself in the class. It does give people a nauseating, it does have a nauseating effect because it feels like you're in a time loop. So that's an interesting thing that I can do in the class, because I can actually slipstream back a few seconds. All right, is that good so far? Okay. All right, so let's get it out of the way, and we'll go ahead and start with developers and algorithms. Okay, so this is what you need to do to study for this class. There's no textbook to buy. Okay, everything is available in Moodle. It is all online. So that means, question? Okay. Well, it's a good thing and a bad thing, because the good thing is you don't have to pay anything. The bad thing is you have to read what I write and not some professional authors write. Okay, because I'm not a professional textbook writer. I make no money out of it, and therefore I cannot possibly be professional, right? Professional means there's a chance that you may be making money out of it. Since I'm not making money out of it, I cannot possibly be professional. But you are expected to read the material, okay? And the best way to do it is to read ahead of me. if I'm teaching a certain topic up to this point in the notes, read ahead of me. Okay, you can kind of gauge after a while, how fast I can get through that material. So read ahead of me so that you know what I'll be talking about in the next class. You may not be able to understand everything, in the material that you're reading ahead, but that's okay. Just write down your questions. Okay, write down your questions and bring it to the class. When we get to that point, then you go through your own question list and go, okay, did Tech talk about this? Okay, yes. Okay, did Tech explain, this item that I could not understand from just reading the notes? Yes. If it is not the case, if I went through a topic in the lecture and you still could not understand a particular topic, just raise your hand and ask the question. So that's the best way to prepare for this class, is just read ahead of me a little bit, and also after the class, review the material. Okay, just review it quickly. Spend 15 minutes to review the stuff that we talked about in the class when your mind is still fresh with that material, and it's much better than having to cram for the exam later on. This class is about understanding, and I can tell you already, the first exam, the second exam, and the final exam, they're all open book, open notes. Okay, I cannot let people bring their computers in because not everybody has a computer. So you have to transfer all that material onto some printed or handwritten form. But it is open. You can bring in anything you want. My notes, your notes. You can work together to come up with quote-unquote cheat sheets. As long as it is done before the exam, it is allowed. In other words, I cannot let someone write down something on a piece of paper and pass on to the next person and say, but you said it's open book and open notes. I just created this note on the fly during the exam. So that would not be allowed. See, I think of all these things too.
Well, the thing is, because you're saying it now, I mean, somebody's tried it in the past. It's just kind of sad.
Actually, I try my best, to try to break my own rules. So I think, well, if I were a student in my class, how would I bend the rules and say, but you said it is okay too? So that's why, I explain that. Nobody actually has tried that.
Okay. No, it's okay.
All right. So let's go ahead and talk about this one. Right away, I can tell you that, there will be no questions about this, section of the notes, because it really is very soft. This is a very soft topic. So it's really hard for me to ask questions about this. And I cannot open this as a new. Do? There we go. All right. So this thing, this part of the notes just talks about computers and software and what is software development, why is it important, and so on and so forth. Because I don't want you guys to take this class, go through all the material, do the homework assignments, take the tests, just because it is on your prerequisite for another class. Okay? How many people in this class are planning to take cisp300 after this? I would say the majority, with a few exceptions. And how many people are on the track of an engineering degree, a computer science degree, or a math degree? That's pretty much the entire class. All right. So let's think about computers and software. Okay. Many of you already know these terms, and some of you may not know exactly what it refers to, but you kind of have a sense of idea of what it is. What is software?
It's what makes hardware run.
It's what makes hardware run. That's right. Okay. So let's say that we have a super duper computer. Okay, maybe not this box, but something that has a lot of processing power. How would you call that computer if it has no software available?
It's a doorstop.
I would go a little bit beyond that and call it a heater. You turn that thing on, it heats up the room a little bit, and that's pretty much all that it can do. Okay? And that's because without hardware, without software, hardware cannot do anything. Okay? Now, a computer by itself cannot really do much. The processor of a computer, as fast as it can do things, as sophisticated as it is, as many transistors as you can pack in a tiny little area, it really cannot do a whole lot of stuff. It can add, it can subtract, it can multiply, it can divide, it can compute sine, cosine, and stuff like that. It's really good at that sort of thing. It can also, continue execution somewhere else. You can tell it, oh, don't follow these instructions. Go ahead and start with those instructions. Okay, but beyond these basic operations, it cannot do anything. So, given the processor can only do those, really, really simple stuff, how can we display web pages? How can we make it so intelligent, they can do spell check when you type a letter and so on and so forth? It's all software. Okay, so basically software is the specification of what instruction follows which other instruction, follows which other instruction, and so on. Okay, if I compare, the body of a person as the hardware of a computer, what is the software of a person? Our mind, exactly. Okay, so that's why software is so important. But what is interesting is the hardware of our computers, particularly digital computers, have seen a lot of improvements over the past 50 or 60 years. Because someone can argue that the true birth of a digital computer started, at the end of World War II. Okay, there were some computers before that, but they were not, electronic for one thing, and they were not really mass-produced or useful for any particular purpose. So the digital computer was born at the end of World War II, and it has been a while since that time, and we have seen a lot of improvements over the performance of computers. On the other hand, the fundamental concepts of programming, writing programs, and so on, has not changed in the past 50 or 60 years. The way we specify programs have changed. Okay, before is punch cards, instructions, specified in binary code and stuff like that. And these days, you can write programs in VB. You can also use graphical environments to write programs. But you know what? That's really just the language. What you're conveying through the language has not changed much over the past 60 years. So we'll go ahead and look at software. For the most part, it's stuff that we have already talked about. I just hate reading my own notes out in the class. It's super boring. So I just focus on certain sentences, highlight it, and say, okay, that part is important. Software is the specification of how hardware components should operate. In other words, use this portion of the processor to add first. Take that result and feed it into this other part of the processor and do a division. After that, take the quotient out of the division, put it over here, for the comparison. And based on the output of the comparison, if this number is bigger than the other number, go this way, and so on. So that specification is software. Okay? In other words, you really cannot see software. Hardware, you can see, even though the transistors are really, really small, with enough magnification, using electronic microscopes, you can see hardware. You really can see it. Okay, here's a transistor, this is the hard drive, this is the motor, and so on and so forth. But software is invisible. But what about that DVD disc that I buy from Fry's? Isn't that software? It's a media so for you to transport software, or install software. But when software is really running in a computer, you cannot see it. Okay. Oh, thank you. Has everybody signed the attendance sheet, including people who are on the wait list or not even on the wait list? So everybody is done with it? Okay, very good. All right. Well, let's think about, where do we find software? Okay. In a classroom like this, people can easily point and say, oh, that computer is running some kind of software, because otherwise we cannot browse the web and look at these documents and so on and so forth. Yes, okay, that's a really obvious one. What else is running software?
Smartphones, PDAs.
Smartphones, okay, PDAs.
Any kind of infrastructure that we have, like power grid runs software.
The projector runs its own software, okay? These projectors are smart enough that they can hook onto the network by themselves, so that I can have a computer that has Wi-Fi capabilities, and I can actually just access the projector using a Wi-Fi interface. Okay, it's all wireless, can be all wireless. So computer software is running everywhere. What about your car? Okay, well, let's just say that you have a car that is post 1990. Okay, does anyone drive a car regularly that is manufactured before the 90s? Okay, so it may not apply to you. If you drive a 68 Mustang, it may not have a computer inside. Neither does it need. It doesn't need one either in that case. Okay, but if you buy any car, after say 1990, it has some sort of computer in it. Okay, the sophistication of that computer, or computers in this case, they get more and more sophisticated. They can do more and more. Because back in 1990, what was the reason to put a computer in a car?
Emissions.
Emission control. Okay, because the Cal EPA wants to make sure the car knows how much emission it's making, and be able to regulate it and be able to check it later on, so it can smoke your car and you can talk to the car. But these days, what can computers do in your car?
Traction control.
Traction control, okay, it is actually mandatory now. Any car you buy today, has to have traction control.
Can't they use it to get a better diagnosis of what's like a problem with your car? Maybe
Yep.
there's something wrong with.
It doesn't matter. Doesn't matter
It
what
can
it
be
is.
anything.
It can be a windshield wiper not working. It can be your engine won't start. It can be one of the cylinders misfiring. Almost any problem that your car can sense, it is doing so through its own computers. Not a single one, because you have one computer for engine control, you have one computer for anti-lock brakes, you possibly have another computer just for traction control, and so on and so forth. Okay? So even though we don't see the computer really, it's there. Okay? It is there. And most cars, I think the last count was at least 10 computers in any car. And that includes the econo boxes, not just Beamers or Mercedes. Okay? So that's one place we can find computers. What else? Where else can we find computers? I mean, cars are pretty expensive stuff, so we can afford to put a few computers in it. What else do we find computers? Where else can we find computers?
Televisions. Televisions.
Televisions, basically all television these days are computers with a big screen. Yep, go ahead.
I was gonna say like really high-tech calculators.
Not even high tech. Your TI-89, okay, entry level college stuff, college calculators. They're all computers. Let's see, where's mine? Right here. How would you call this?
Computer.
Yes. Well, I know you guys are looking at the thickness of my cell phone. It's an extended battery. Okay, it gives me about 4 days worth of battery reserve, which is good for camping. Yeah, so it looks a little bit big and bulky, but it works. Yes, I would call this a computer, but isn't that a phone? Well, it pretends to be a phone.
Pretty much, it's got hardware that makes it a phone too.
Yeah, it has just the components to turn it into a phone, but it really is a computer first. It's only pretending to be a phone. Okay. What else? Where else can we find computers? Calculators. Okay. Cars. What else?
Game systems.
Game consoles. Okay. Every single game console is a computer. Okay. They're mostly locked down so that you cannot get in and make changes or copy games, but they're computers nonetheless. Where else?
Televisions.
Televisions. Okay. Anything else?
Your watch.
Your watch.
Routers, switches.
Routers, switches, they're all computers. They're dedicated computers with a special purpose, but nonetheless, they are computers. What about something cheap? Try to go for cheap stuff. Okay, because we're talking about expensive stuff, we can actually put computers into. What about cheap stuff?
Digital watches.
Digital watches. Okay. Well, in the notes, I mentioned Furbies. Okay, now obviously that reference will become more and more obscure over time because younger people don't even know what is a Furby. Okay, what exactly is a Furby? Can someone explain what a Furby is?
It's an electronic pet.
They're a really creepy furry doll that people get it as a kid, and it talks and
And when did Furbies come out? You know,
90s.
in the 90s. Okay. Well, you know, whenever we have questions, we go to Wikipedia. Don't tell your English teacher that. Some professors have problems with using Wikipedia to get information. Okay, so we'll go.
Just citing it. It's a Y.
Okay, Furby in Sweden. So Sweden actually has their own Furbies. Okay, so a Furby was a popular electronic robotic toy, and it was released sometime in 1998. That's about 14 years ago. Okay, that's a long time. And what can a Furby do? Well, a Furby, amongst other things, can do certain things. It can imitate the stuff that you say. Okay? Well, you can kind of say that that's pretty easy to do. But Furbies can learn from each other too. Now that is the creepy part. Okay? If you have a Furby and your friend has a Furby, you can actually have the Furbies to face each other. They have IR communication, capabilities. So the two Furbies can exchange their vocabulary, what they have learned. So one day you get your Furby back and it starts to swear, you know where it learns it. Okay? But isn't that telling you that there has to be some kind of computer running inside a Furby for not just learning or imitating what you say, but also learning from another Furby? There has to be some sort of computer running some kind of software to facilitate the communication. And how much was a Furby? Let's see. It has to be here somewhere too. 2005 revival. I missed that.
$35.
So the original price, resale price, is over $100. Where? Oh, right there. Originally retail for $35. That's not too bad, considering it was 1998 and it has computers inside. Okay? Now, how can they do that? How can they put stuff a computer inside a Furby? Let's not even worry about the size or the power consumption part of it. I mean, how do you shrink something like this into a little stuffed animal?
Have you heard about the Raspberry Pi computers?
Mm-mm.
They're like a little 700 megahertz little processor computer that's about like that big.
Cool.
But they're running Linux.
Oh, they can run Linux. That's the.
Well, that's about all they can run, but they're going to be used for educational purposes. I mean, that's pretty dang small.
Well, let me look up some parts for you. This is a resource for people who are into designing circuit boards and stuff like that. And what I'll do is I'm going to look up one of these things. And we'll go for number of I/O, let's say 6 I/Os in stock. Go ahead and take a look. Okay, these are chips, right? Integrated circuits. And each one has 8 pins. Let's look at the price. $1.07 each. When you buy one, okay? If you buy a lot more, it gets cheaper. If you buy 100 of them at the same time, it's 60 cents each. Okay? If someone just skips Starbucks for one time, how many of these chips can that person buy?
2.
A few, okay? So the question is, wow, but is that really a computer? I mean, it looks like a chip, an integrated circuit of some kind they can put into a circuit board. But what is it? It really is a computer. Not only is it a processor, it also has the RAM and also the flash to store a program. It is completely standalone. All you have to do is to give it 0 volts, which is what we call the ground, and also 5 volts, and it will run. Okay, you can program this thing to run, software. In other words, it can sense what the pins are experiencing in terms of voltage. You can also, change the voltage at the pins to turn on and turn off devices. And it's only 60 cents when you buy 100 at a time. Okay, that is how cheap processors have become. And they can also embed this into very small devices too. How big is this device? Look at your pinky, the size of your pinky. You can probably fit about 2 of these chips on the fingernail on your pinky. Okay? But what about power consumption? How long can it run? Any guesstimates?
Well, it's not very big, so it's got to be able to run for a long time.
It will run for a long, long time, even on a single, AA battery. Okay? So suddenly, all kinds of possibilities open up. You can actually make a device, for your backpack. Okay, what kind of a device? Well, let's say safety is a big deal, and you want to improve the safety when you wear your backpack, just walking or on campus, off campus, and so on. You can have one of these things to sense the light level and automatically turn on some LED blinkers when it's getting too dark. Okay, well, that's actually very easy to do using one of these things. You can also attach one of these things to a distance sensor. Okay, there are sensors that you can buy that can sense object at a certain distance. So if someone or something is approaching from behind at a certain speed, this thing can alert you and go like, oh, okay, bogey at 6 o'clock, right? I mean, it's entirely possible with these things. Okay, so all kinds of possibilities open up. Well, the device is really cheap. What do you think is expensive, when you're considering a backpack that has the intelligence, that can do this, that, and whatnot?
Manpower.
Yep. The manpower to program it, exactly. Okay, because programming is the difficult part when you design something like that. The circuit is almost, really, really easy, but it is writing the software on this thing that can do all of those, things that I mentioned, that is difficult. Okay. It's even more difficult if you want to be able to update the firmware of these things by Wi-Fi, so you can update the firmware of your backpack now. What about torque wrenches? I mean, I don't know how many of you work on physical stuff. Torque wrenches. How can a torque wrench use a computer or chips like this?
Like the new modern Snap-on torque wrenches, they have a little computer inside. You just type in the torque that you want, and you go ahead and torque it, and it vibrates when you hit that torque.
Yep.
You let off, and it stops vibrating. You hit it again, and it vibrates again.
Yep, exactly. Is that what you were planning to say? It's also good for training too. Okay, let's say that you run an auto shop. We have a automotive technology department here, and you can assign each student a torque wrench with one of these processors. They can talk through Bluetooth or some other wireless means. So let's say the class tells students, okay, we want you to disassemble this part of a car engine. Okay, and as the students start to disassemble stuff, the instructor can probably monitor the torque of each and every single wrench. So if someone is over torquing a nut, the instructor can tell right away and say, hey, don't over torque that thing. You're going to strip the threads on that particular thing. That's what you can do with torque wrenches. Okay. Does anyone have what's the name of that thing? The pen that can also record in
LiveScribe?
Yep, LiveScribe. Okay. Does anyone have a LiveScribe today? Okay. That's a pretty sophisticated computer there, because not only can it record the audio part, but it can also record what you're writing at the time. Okay. So all of those are computers, and the difficult part is software. Now, why do we know software is the difficult part to deal with? When was the last time that you have to send something in, to have the circuit, readjusted or repaired? Not very often. Okay. How many times do you have to update the software of stuff these days?
All the time.
All the time. And it's not really just your cell phone. It's not just your computer. Does anyone have a slightly higher end Canon flash for single lens reflex computers? Nikon. And they have a USB connector in the inside. Why?
To update the firmware.
To update the firmware, exactly. So every time they release a new Nikon body, they might enhance the body to do certain things that all the previous bodies could not do. But in order to utilize that feature, they might need to change the firmware of the flash so that the flash and the body of the camera can work better together. And that's why they need to be updated. Okay? So what about the lenses of a camera? It has its own processor. Okay? So the stabilization of the lenses is all done by its very own processor. So we are talking about processors everywhere, and because of that, we're talking about software everywhere as well. All right, so I think we have established the importance of software. But software is not magical. It just doesn't pop up from nowhere. So where do we get software?
From programmers.
Programmers is kind of the old term. We tend to call these people software engineers these days. And the difference is really subtle, but it is important. So for those of you who want to know the difference, you can go to the United States Bureau, Bureau. How do you spell Bureau?
R-E-A-U.
B-U-R-E-A-U, Bureau of Statistics. Okay, you can go to their website. And this is a really good website, especially for those of you who are still kind of planning, what should I study, what kind of occupation should I consider, because you can go to that subject area and you will find math and professional stuff laid somewhere in here. Oh, come on, where is it? Employment projections. Okay, so under employment projections, you can look under subject areas. No, that's where we were.
Are you looking for employment by career?
I'm trying to look for computer science occupations.
Go down a little bit. It says employment by occupation.
Ah, okay. Data search, industry data search.
No.
I'm sure it's there. Okay, let's search for computer science. There we go. And these are, well, anyway, I'll look up, next time I'll show you exactly, where it will list different occupations related to computers. They have database management, system administration, network administration, computer science or computer scientists, programmers, and so on and so forth. So they break it down into really fine categories, and they'll show you what you need in terms of education to get into that occupation. They will also tell you what type of work are typically done by people in that occupation. So I'll look that up and do some research next time so that you can see it. But yes, but what we were talking about are the people who come up with the software. They're also called developers. And some of you may know the importance of developers, because if you look up BOMA developers, you will find some interesting or entertaining YouTube clips. Okay, and I'll just find one of these. I don't want to have a remix version because I want the version that is actually real. Going crazy. Okay, maybe the 20-second one is the real version. We'll see.
Developers, 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 developers. Developers, 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 developers,
So this one is not a remix version. It is not, people did not make the repetition by special effects. He actually said developers that many times in one of the conferences, because Microsoft, I think that's during a time when they had a really bad relationship with independent VB developers. So he was trying to kind of make up for that relationship. Sorry? Okay, because without developers or software engineers, there won't be any software. Without any software, hardware is useless.
So what happened to Palm? Palm.
Pong?
Nobody developed for the web OS.
Yeah, that's really sad. You know, it really is. You know, I had a early Pong, you know, and I had a Trio, and I thought it was, at the time it was one of the best. And they stopped, you know, the development. You know, they could not decide where to go, and they let, you know, Android and iOS take over. They had a head start way, you know, before the other ones.
Yeah, the web OS, that was beautiful, beautiful. But they're making it open source. Did you hear about
Yeah,
that?
but they did it too late, you know, and they did not really promote it, you know. So it was really sad. Yeah. Okay, so we know that who wrote the software. Okay, you know, people who develop software are called developers, programmers, or, you know, these days you want to refer to those people as software engineers. There's a slight difference between, you know, what is a software engineer versus who is a developer, and I'll explain that when we talk about systems analysts, developers, and testers, system testing people. Let's think about, you know, building a house. Okay, we are still on, you know, soft topics right now. Let's think about building a house at this point, okay? And the house is basically the software of your computer system. It doesn't matter what system we are talking about. It can be an e-commerce system. It can be, you know, an application on your iPhone or Android phone. It doesn't matter. But we are basically trying to write the software. But we'll use the analogy of building a house. Okay, so you found this really nice, you know, place somewhere on Highway 1, you know, with a nice view of the ocean on one side, and the other side is back up the mountains, you know. So it's a really nice view. In other words, you found a really good idea as an iPhone app or an Android app. But you don't know how to, you know, develop your own software. So you need to, you know, have someone to write your software. When you build a house, who do you contact first? What type of people are the first ones that you need to contact? Let's just say that, you know, legally you have that piece of land already, so legally everything is done. Yep. Sorry? An architect, very good. Okay, an architect is the first person that you have to contact. What does an architect do?
Draw.
Designs the house.
Hmm?
He designs the house.
It designs the house. Okay, go ahead. Okay, but how does an architect know how to build your house or how to design your house? Yep.
He talks to you and see what you want. How many bedrooms, how many bathrooms.
Exactly. So an architect, you know, really does not design the house out of thin air. The architect will have to interview you first to find out what do you want in this house. Okay? Well, because this house is right next to Highway 1, it has an ocean view. Maybe you want this house to have a very open, you know, side, you know, with all glass panels. You know, maybe you want, you know, certain features, you know, that you want in this house. So the architect will design the house to basically, you know, fulfill all the things that you want. Okay. If you say, you know, I want my patio to extend beyond the cliff, you know, by, you know, 50 feet or so that people can walk out the patio, and it's almost like they're walking in air, looking down to the wave, you know, crashing into the cliff. The architect can design it, not a problem. Okay. Next, who do we get next after the architect? An engineer. All right, but what does an engineer do when you're building a house?
Tells you how feasible your plans are.
Exactly. Okay. Just because the architect can design a house doesn't mean the house can be built safely. Okay. So the engineer will come in and say, well, we kind of need to make some changes here. If you want the patio to extend 50 feet out of a cliff, we need more supports, okay, for that patio. Okay. So, you know, it may not look as good anymore because the architect would just draw a flat piece of plexiglass out, you know, 50 feet into nowhere, and then the engineer says, no, we need some support there. So now you have, you know, different supports under the patio, so it's no longer an obstructed, you know, view, you know, down to the ocean. Okay, but that's important because you need to make sure the house can be built and safely too. And then what do? Do you ask your architect or your engineer and say, well, here's a here's a whole suitcase of cash. Go ahead and build a house for me. Yep.
No, you need need a general contractor.
You need a general contractor. Now here comes the big question. How come you cannot ask the engineer to build your house? I mean, after all, the engineer knows the design, knows all the safety rules, all the calculations and whatnot. He is the last one, he or she is the last one to touch up the floor plan, the blueprint. So that person really has all the information that someone needs to build a house. But why? How come we do not have the engineer build a house?
Use the tools necessarily.
Sorry?
Maybe they don't know how to use the tools necessarily.
That's okay. That's what my suitcase of cash is for. I mean, if you need some tools, use it to buy some tools.
Engineers work in theory versus application.
He or she may not have the expertise to actually build a house. Okay. Now, let's think about these terms here. A systems analyst is kind of a combination between an architect and an engineer. Okay, so a systems analyst actually has to do both the design and also make sure the design is feasible. It can actually be done. A developer, on the other hand, is more like a general contractor. Okay, in other words, the systems analyst or system analysts in some cases will produce the blueprint of the house, of the software, and pass it on to the developer. The developer will actually build a house or write the code according to the blueprint. And this is where the term software analysts or software engineers come in. A software engineer is kind of somewhere between these two. In other words, a software engineer can do some of the design, some of the analysis, and some of the development. And that's the main difference between a software engineer and just a developer or a programmer. A programmer is a developer which basically takes the blueprint and start from a blueprint. Okay? Any questions at this point? No questions? We have about 2 minutes remaining, so I'll go ahead and start on that topic. Who do you think will make a good programmer, a good developer? Someone who's good at writing software.
Somebody who's good at math. Somebody that's good at math.
Someone who's good at math and logic. Okay, that's very, very important. What else? What makes writing software so challenging? The syntax? Yep, go ahead. Sorry? Long and tedious, okay.
It's very detailed.
It's very detail oriented, yep.
It's how you approach the problem.
It's how you approach the problem, okay? Very good. Those are all very valid points. But one of the most important part of being a developer or someone who actually deal with software is debugging. How do you use logic to find out where a problem is? Now, when people think of developers or programmers, they have this fantasy. Oh, they're just writing new code, new programs, really cool stuff every day, every hour. Well, the truth is, most of the time they're fixing stuff that somebody wrote 20 years ago with no documentation. Okay, and the program is not working anymore. It's broken. It needs to be fixed last week. Okay. So that, I think, is the most important qualification of a good developer, is how can you apply logic to solve a problem. The problem can be, okay, here's a new problem. It has no known solutions yet, so go ahead and develop a new solution for this new problem. It can also be, this is a program that we have been using for 20 years. Now we want to add some features to it. It can also be, this software also has a bunch of bugs that we could not fix because we could not afford it. Now I want you to fix it. Most of the time, out of university, as a fresh graduate, your first job as a software engineer or programmer or developer, guess what? Is to
debug.
Yep, basically clean the toilet. Okay, that's your job with a toothbrush. Okay, so they will assign you to a task. Okay, here's some legacy software. We want this particular bug fixed. And why do you think that's a good thing for a beginning programmer to do in an organization?
Gives you a lot of experience working with the nitty-gritty of stuff, so you can, as you go up, you can see the larger picture.
Exactly, because it gives you the exposure of the product. Okay, it's also a good way to weed out people who do not want to do it. Okay, So we are running out of time today. As I said, this is really soft stuff, but read it anyway. Next time.
How far would you like us to read to?
That's a good question. How far do we want you to read? I want you to read. I would say, finish up variables, expressions, and sequences. Okay. All right. So what I'll do is I'm going to find out how many people are absent today from. Oh, only one person is absent today, so I only have one spot for one person on the wait list. I'll send an email to that person. Okay.
I'll tell you if I get your email address. Maybe if I'm like having trouble.